Moving on to the question 2, we have plenty of different types of topics here. We have about polar equations, different types of cones, graphing polar equations. We also have De Moivre's theorem, imaginary form of polar equation, and distinct roots, I believe. We will do all the topics one by one. I will solve one question of each topic thoroughly, and the other questions must be solved by yourselves. If there are different types of topic, I'm going to solve all those different types. Now, the first one is a very simple one to determine eccentricity, type of conic, and the equation of directrix. Before I begin to solve the problem, let me write some important formulas. You might know the polar equation of any cone is given as R equals, this is E, that is eccentricity times directrix, divided by 1. Always this number is 1. It's either plus or minus. First, you can write it as sine theta, and the same thing can also be given as 1 plus or minus cosine theta. I missed something. I forgot to write E over here. There is E sine theta, E cosine theta. So this is the standard, this is the general formula. Now what happens? What is the difference in sine and cosine? There's a huge difference. Here, E is eccentricity. Whatever the number is there, that is eccentricity. If E is equal to 1, then it's a parabola. And then if E is less than 1, then it's an ellipse. So always remember this distinction. And when E is greater than 1, it is hyperbola. This remains same for both of this. E value is eccentricity. When E is equal, this all the same. Now, one important thing is if it is sine, the directrix line is given as y is equal to, okay, plus or minus. I'll tell about this in a minute. Whereas if it's cosine, remember it's x is equal to plus or minus. If you have plus in the denominator, then your value of y will be plus. And if it's minus, it'll be minus. Whereas over here, if you have minus, say it was 1 minus 3 cosine theta, then the value will be x equals minus the directrix value, which we will solve. I hope this much is clear. This is some basic things. Now, with this information in your mind, we can solve all these problems. But since it's in writing, I will write the steps as well. If you follow whatever I've written, it's more than enough. Now, first thing, always look into the given question. It is in sine and plus. So I'll write the standard form of sine and positive sine. Plus E sine theta. This is your step 1. What next? Next, what you do is, you don't need to write the question again, but you can. I'll just write it over here. 20 divided by 4 plus 4 sine theta. It's up to you. But this step is mandatory, the step 3. This is optional, okay? If you want, you can write it because it's writing exam. I'm just writing it. Optional step. This is important. Now next, this must be written. And next one over here, E times D. No, leave that over there. 1 plus E sine theta. Leave the sine thing, but this 1 can be easily done because I know it's not 1 over here, it's 4. So I just divide everything by 4. So what I'm doing is 20 divided by 4. And over here, 4 divided by 4 plus 4 divided by 4 sine theta. So if I simplify this, I will get a form of the standard form. Since now R equals 20 divided by 4 is 5. So 20 by 4, and over here it's 1 plus 1 sine theta. This is it. Now we can see this is corresponding towards the standard form. It's much easier to understand. Let's see what are known here. One is, when we get this one, stop. No more further simplification. What is the E value? E over here is 1. So E value is equal to 1. I told you if E value is 1, then it's a parabola. So the conic is a parabola. And what next? You can write eccentricity. You know, the first thing, write this term and then write E is equal to 1. Then type of conic. Okay, beside this or above this. And then write parabola. And then what is the equation of directrix? Since it's sine, I have to write y equals, what is the sign over here? Positive sign. Okay. When I meant sine for the first time, it's sine theta. Sine theta is y. If it was cosine theta, it will be written as x. And this positive or negative value denotes plus or minus for the directrix. What is the d value? We know the numerator over here is e times d, right? So how can I get d only? All I need is to divide this by e. So basically e times d is how much? E times d is phi, and divided by e value. What is e value? It's 1, so answer is phi itself. So it is plus phi. These are the three answers. Also, you can write this as a simplification, e times d, right? What is e? It's 1. 1 times phi can be written as 1 plus 1 sine theta. This is the exact form. You can see even ed is split out. So these are the important answers. This is it. But don't just write these answers. I know if you have practiced well, you can just look in this equation and you can easily tell what is the e value. Just looking at the equation, if these two are same, it's a parabola, and then over here e value is 1, and just divide this by the e value and you'll get the directrix. But don't do that because you need to do the steps. Okay, this is writing part. Do the steps and then get the answer. You can see here that's the answer. Let me do another type. Okay, we have cosine over here, and it's not even a parabola. It's not a parabola now. So let's do this type as well. First thing, the standard form, r equals e times d divided by 1 minus, because it's minus over here, e cosine theta. Now I'm not going to write the question again. I'm just going to look over here. It's 2, so I have to divide everything by 2. So it's 18 divided by 2 divided by 2 by 2 minus 6 by 2 cosine theta. Next step. 9 by 1 minus 3 cosine theta. So what is the e value? From here I can easily tell e is 3. If it's more than 1, then it's a hyperbola. The conic is hyperbola. Okay, and then what do we know? What do we need? Directrix. Directrix. What is it? Cosine. Cosine means it's x is equal to, and it's minus over here, so I write minus. And let's see what will be the value in a minute. So here I have got ed, that is 9, divided by e value is 3, so it's 3. So that's the answer. But I would highly encourage you to write this in the simplified form as well. Write these two numbers. It's 3 times 3, so E and D, divided by 1 minus 3 cosine theta. This would be full marks. If you write so much, absolutely full marks. So that's the answers. Now please remember, it's not y here, it's x. Why? Because it's cosine. This one, you guys can do it by yourselves now. It's very simple. Why? Because over here it's already 1. You don't need to divide anything. It's the e is 3 value, value of 3, and this is cosine, so it's x, and divide this by 3, it'll be 7. So directrix is plus 7, and this is a hyperbola. So here you can see that's the answer. Now why is it x? Because it's cosine. If it was sine, it would have been y. Now this one, okay, this is about ellipses. So I'll just do this one as well. Why? Because see, it's 8, and over here it's 4, it'll be 0.5. So now let me write the standard form. It'll be e times d divided by 1 plus e sine theta. You can write this e sine theta as first as well. It's up to you. I just write this standard form. And then now here, I'm not going to write the question. I'll directly divide everything by 8 because I need this term to be 1. So 24 by 8 divided by 8 by 8 plus 4 by 8 sine theta. Now then, this will be 24 by 8 is 3. 24, yeah, it's 3, and then over here it's 1 plus half sine theta. You can write it as 0.5 as well. So E is equal to half, or it's 0.5, which is less than 1. So the conic is an ellipse here. So what is the directrix now? It's sine, so it's y is equal to, it's positive, so plus. But how do we get that? All you need to know is ED divided by E. What is ED? It's 3 divided by E value is 0.5 or half. When you divide half, it'll just multiply above, right? It'll be 6. So the directrix is 6. Or you can write this as 0.5 times 6, which will be 3 itself. 1 plus 0.5 sine theta. So these are the answers. And here, remember, it's sine, so it's y, and less than 1. The eccentricity is less than 1, so it's an ellipse. And these are the answers. Similarly, please do solve the other problems. They're all straightforward problems, and you can then check the answers. Solve it by yourself and only then check the answers here. So here as well, this is the answers. And here, you can just pause the video here and look into the answers for more details. And now this one is a real world problem. The Cassegrain telescope, invented in 1692, produces an image by reflecting light of parabolic and hyperbolic mirrors. Determine the eccentricity type of conic. Okay, the same thing they have asked of this particular telescope. Let me just do it over here. Looking at this, I know this is a parabola. Why? Because these two are same. Let me just divide everything by 2. Now you have to do the same method like the previous one, but I'll just jump to the answer here. R equals this divided by 2. Then over here I have sine theta plus 1. E value is 1. It's a parabola. Why? Because E value is 1. Bola. And then the directrix. Here sine, it will be y plus, because it's positive over here. And 1 times this much is just this, 3.5. Done. What about this one? Here, I need to divide everything by 5. So it's 28 divided by 5 divided by, now 12.5 divided by 5 cosine theta plus 1. What's this? It's 2 times. 2.5 goes 2 times. 4, 5 times. 5 by 2 is 2.5. Answer is 2.5 here. So E value is 2.5. Now this is more than 1, so it's a hyperbola. And lastly, what do we want is directrix. D value would be this about term, 28 by 5 divided by 2.5. We'll just put this in the calculator, it'll be much easier. Here, let's just put these values, 28 divided by 5, and then I can just do divided by 2.5 outside, or you can just put another fraction, it's the same thing. It's 2.24. So the D is plus 2.24. You can see the answers. This was, yes, for the first one. E is 1, parabola 3.5 positive, y. But here in the second one, it's x is equal to, see the directrix, x is equal to 2.24, which you just got in the calculator. E value is 2.5, and it's a hyperbola. Hope this is all clear. So that's it. Now, in the next type of problems, what they have given is, they have given you the E value and directrix of y is equal to 6. We need to write the equation. Now, looking at this, we need to write the standard form first of all. E value is 1, so I know the conic. See, let me just write the conic is parabola. Why? Because eccentricity is equal to 1. The standard form, R is equal to E times D. This much doesn't change for anything. 1 also doesn't change. Look here, is it plus or minus? It's positive 6, so it's plus. So this much you can write for anything. Y means sine or cosine. It is sine, sine theta. And E. So this is the standard form. Now I know E values over here. Directrix, that is the above term, entire thing is, the D value, that's 6. That's it, right? Now to write the standard form, I can just substitute everything what I know. R remains as it is. E value is 1 times 6 divided by 1 plus 1 times sine theta. So what exactly they want? Oh, they need to, you need to graph. Okay, we'll write the graph in a minute. But directrix is given. Okay, this is it. The equation is found out. Now, how can you graph? There are various ways to graph. Let's just go to the graph and I'll then tell you about it. Now, we have written it in terms of E times D. They have directly written 6. It's up to you. It's both are correct answers, okay? Now, here then, we know this was the equation, right? If you recall, y is equal to 6 directrix, it'll be somewhere above. For parabola, this is very easy. You just draw the directrix on the line like this, and the parabola will be down, way down. From here you will have to take 6 and 6 beside, and then you can just draw the points. But the better way, I'll tell you, in the calculator. Now for better accuracy and everything, just use your calculator. Let's clear our calculator first. Shift 93 equal AC. What I do is whenever I do a table, I just clear it off. It'll be in default mode. Now let's go to mode, and we have to go to 7 to put the values, to get the values, the table of values to graph. What is the equation here? 6 divided by 1 plus sine, that is over here, x, theta is x. Now you can choose in terms of radians or degrees. Now trust me guys, degrees is much easier when you're doing a table method, because if someone tells me 90 degrees, take the value of 4, okay, it's much easier for me to understand. Whereas if you tell me it's pi by 2, it takes me time to understand pi by 2. Pi by 2 is okay. What if I tell you pi by 6? Pi by 6 is 30 degrees. It's much easier to understand if someone tells you in 30 degrees rather than pi by 6, isn't it? So that's why what I'll do is I'll leave it in degrees. See, this D is for degrees. And now press equal to. Some of your calculators will get this option, the latest models. Just ignore it, leave it. We are just graphing for one equation. Most of your calculators, if you're using this sort of model, you'll not get that option. You will directly see the start option. Always memorize this for graphing polar equations. Start is 0, end is 360 degrees. And give a step of 45 degrees, not more. You can go with 30 degrees, but 45 degrees is plenty. Okay? Now you get these values. What are these values? See, the left side, you can see that is the radius r. At which degrees? Sorry, that's degrees. Okay? X value, because we have put theta is x. The right side is the r value. Okay, this is the radiuses. Now at 0 degrees, the radius 0 degrees is over here, straight ahead, right? What is it? 6. Is it at 6? Yes, it has to be at 6. Next one, 45 degrees. 45 degree line would be just middle line. See, this one is 30, 60. No, this is 45. Okay, over here it's 90, right? Half of 90 is 45 here. Is that 3.51? See, this is 6. It's less than that. Yes, it's about 3.51. You just have to see, you won't have a graph. You will be given a polar grid. You just have to mark a point over there. Doesn't matter, it's not that accurate, it's fine. Just approximate accuracy is more than enough. Then look over there. You can see at 90 degrees it's 3. Okay, this is 3 because the next one was 4. This is 2, 1, 0. Now what about the next? Again, 135 is middle of these both. 180 and 90 is middle. That is again 3.51. And then we have 6 here. Now what happens is, if you go down 225 degrees, it's in the middle over here. It's very, very far. It's 20, right? That means you may not have that grid properly. It's about this point. See, over here somewhere, this point. Okay, just approximately draw it out. And then over here, what is 270 degrees, by the way? What is this line? It should be an error because there is no point of graph at that particular line. Only at 90 degrees there, not over here. So it's an error. And then you can see the same thing repeats until 360 degree. When you go to 360, you complete a rotation, right? Like this. And that is at 6. Now we know this is a parabola. Why? Because the equation was of a parabola, eccentricity is 1. Now you'll get so many points. You should have some basic understanding. Just graph these together. And okay, parabolas go like this. And then the directrix is about over here. That's given over here. Y is equal to 6. It's not x. If it was here cosine, then you have to draw something like that, directrix. And if it was at the left, then your parabola would be at right. And imagine your directrix is at the right side, parabola at the left. So that's how we basically graph. You can use this method for any of the conic sections. Look, the next problem. I won't do the entire problem, but I'll just show you the graphing. Over here, you can see eccentricity is 0.75. So what is it? It's an ellipse. And it's minus, so it's minus, and x is given, so it's cosine. Okay, you got this equation. So now what you do is, you can just go to mode 7 and type in the equation. 6 divided by 1 minus 0.75 cosine x. Close the bracket. After this much is done, what do? Press next. You should get the start option. Press 0 here and then 360 degrees. See, if you're doing multiple problems, this will be repeated, but now I'm just doing it from the beginning. That's why I'm typing all the values again. Always start at 0, end at 360. Step is at what regular intervals do you want the values. Don't give 1. You won't get an answer at 1. You need to give 45. So memorize it. Start 0, end 360, step 45. Now look over here at 0 degrees. What's the value? Is it 24? Yes, somewhere over here is 24. At 45 degrees, this line, is it at, see, this is the middle line. Is it at 12 point something? Yes, this is 12. It's just more than 12. And at 90 degrees, it's at 6. Yes, it's at 6. And at 135 degree, it's at 3 point. Yes, absolutely, that's correct. 3.9. And you can see all the values will match. But you won't have any graph, so you just get some points like this, and then you just join them up. It'll be it's not very accurate over here. You'll get some values like this. Then it's an ellipse, so it'll be oval shaped. Join them up. Similarly, in this problem as well, we can use the standard form and solve it. But look at the e value. It is more than 1, so we know it is a hyperbola. Hyperbola. And now how we solve it? Let's write the standard form. R equals E times D. Doesn't matter what, all the equations are the same thing. Plus 1. Now plus because it's positive 2 over here. If it was minus here, we write this minus 2. X is given. If it was y, it is sine. X is cosine theta. So this much is done. Now let's substitute and write the equation. What is the e value? E value is 5 times 2 divided by 1 plus. Oh yeah, I forgot to write e again. So e is over here 5 cosine theta. Let's simplify this. It'll be 10 by 1 plus 5 cosine theta. This will be the final equation. Now we can graph it using the calculator. Just let's look at the graph now. You can see this is 10 by 1 plus 5 cosine theta. Let's take our calculators and let's graph. So let's write this equation over here. It's 10 divided by 1 plus 5 cosine theta. And now we have it in degree mode. Let us press equal to. Ignore the second g of x. In some calculators, if you get it, just ignore. Go to the start menu. In the start option, you need to start at 0 and end it at 360 degrees. And now the step is 45 degrees. See, you're getting some values. Let's compare these. Now there are two curves over here in hyperbola. You will get both the curves values, not all, some of them, okay? The directrix is at 2 and now we are getting at 0 is 1.6. So obviously this is the vertex of the one which is at the left of directrix. So that is 1.66. Okay, yeah, that is accurate. What about 45 degrees? 45 degrees is this one over here, that line. How much is it? 2 point something. Yes, it's 2.2. That is accurate also. What about 90 degree? It goes to 10. See, it extends, right? Okay, we can just ignore that because that's way off. These 2 points are more than enough over here. Let's see the other points. What about 135? 135 is somewhere over here. That's in middle of 90 and 180, isn't it? Now you can see it's minus 3.9. So let's take it backside. 1, 2, 3 point something. See now these negative values, 225, but on the other side, negative side, right? We take it over here. These will be for the other curve. So you can see it's 3.9. If I carefully mark this line, it's 3 over here. It's very close to 4, but not close. Yes, it's 3.9. So that is the point. That was for minus 135. Even for 225, it's the same point because they're symmetrical, right? So 225 is over here. Again, 45 degrees. Is it true? Yes. These 2 points are done. What about 180? Now look over here. 180 is this side, right? But minus to the other side, you're getting another point. That is right side of directrix. So we are getting points on both the curves of hyperbola. And you can see the other points and mark them accordingly as well if you want. See over here, for example, 315 is over here. What is 2.2? That is this point. You're getting this point here. Okay, that's 2.2. So you got 3 points here, 3 points there. That's more than enough. Just draw them, join them by drawing a smooth curve. And you know the directrix are there. These are 2. So that is how we can graph it. No need of complete accuracy, just a rough sketch. As long as you point the points properly, mark the points properly, that is more than enough. So that's how we can solve this graph. And similarly, you can try these by yourselves. Over here, this is ellipse, because it's less than 1. 0.1 is less than 1. So it's an ellipse here. You can graph it like this. It's a very small one. You can see the values. If you graph it, you're going to get this one. And the directrix is given, so it's very easy. Please do solve these problems by yourselves and then check the answers. This is a hyperbola, but directrix is at -7. Now, when you graph it, you will get points of both the curves. You can easily distinguish between the points because some will be over here in this one and some will be far away. Above the directrix, that is this curve. If it's below the directrix, these are the points. So whichever are over here, just join them smoothly, and over here as well. So try these by yourselves. Over here, eccentricity is 1, it's parabola. Now, what if you have been given 2 points like this? They have given you vertices are at so and so. The E value for the eccentricity value is 0.8. So I know it's a parabola. Let me write the equation. R equals ED divided by 1. Now the problem for me is I have no clear picture whether it is cosine or sine, isn't it? So let that be for now. Plus something, okay, some trigonometric equation, theta. From the given vertices, we can find whether it's sine or cosine. Let's see, where are the vertices? -36, that's x and y. Somewhere over here, 36 and 0. And then 4 over here, 4, 0. Now, what's it along the x-axis like this, right? Now, when it's oriented along the horizontal axis, it'll always be cosine. Whereas if it's oriented along the vertical axis up to down, it'll be sine. This is one important thing you must know. And now there's one more thing. What is this directrix value? You can just assume the directrix to be right or left. If you see the shape over here, the midpoint is somewhere over here, so the directrix will be at the right. Okay, so this is one more thing that will help you to tell which sign it is. It's plus E cosine theta. If it was, to the left, in the sense, now let me just draw ellipse over here, then the directrix would have been at the left, something like that. Okay, this is one thing. Now with this information, we can easily try to solve for the directrix. I'll tell you how. Again, I'll write the form. It's E times D divided by 1. And now I told it's cosine theta, and over here there is a E value. Now for this same equation, this is not E over here, it is R over here. For the same given equation, what I'll do is, I'll just substitute one of the points. I'll substitute the right side point, which is very easy to substitute. R and theta, right? R is 4, that is equal to E is 0.8 times unknown value D divided by 1 plus 0.8 cosine. What is theta? Theta is 0. Now let's solve this up. Let's put in the calculator. You can directly put this entire thing in the calculator and solve. So we can do like this. 4 equals 0.8 times x. That D value is what we are solving for. And then 1 plus 0.8 cosine 0. Close the bracket, shift and solve. And equal. The answer is 9. Here the directrix is at 9. Where x is equal to 9. Why? Because it's cosine. We know for cosine x is equal to, and it's positive 9. You get it in the answer. And also there's one more important thing. What is it? Because we saw the midpoint is somewhere over here, the directrix will be at the right side, plus 9. So that's the answer for the directrix. The graphing, we have already done this equation. You can graph it out easily. If you know the directrix is at 9, so 9 times 0.8 is 7.2, and then the remaining equation. Now this problem here, E value is more than 1. And now since this is hyperbola, the way of solving is a little bit different. It's not so simple as the others. because we have to graph hyperbola, and graphing hyperbola is little different. First of all, let's write the standard form. That will be r equals e times d divided by 1. Now here we have no clue whether it's plus or minus. You have no idea. And we also do not know whether it's sine or cosine. So let us just understand it by from the vertex. It's minus 3, it's somewhere over here, minus 3 comma 0. And here we have minus 15 comma 0. See, for these type of problems, you will have easy points to analyze. It'll be either 0, 0 or up and down. So it's easy to analyze. And we know it's like this. These are the vertices. That means we will have one graph like that, and over here it should touch the vertex points. Okay. So what happens? Where will the directrix be? It'll be either over here or over here, somewhere over here, right? It's not at the center. Directrix will be somewhere over here or over here. There are two possibilities. We'll see it in a minute. So then what do we write here? It's in the negative axis, so it's minus and it's up to down. It's a straight line. So over here we can write it as cosine, because cosine means x equals, right? It is cosine theta. And over here there is E as well. So this is the standard form. Now what can we find? We cannot find the directrix from just these. What do we know? We have to first remember, in order to find the directrix, because they want the polar equations and directrix, right? It takes a bit of time. You need to know what is this value over here exactly. What is that value? That value is 2a. If you recall hyperbolas, that total thing is 2a, and that is 15. This much is 15 minus 3 is 12. 12 by this is 12 over here. How did I do that? The total distance from here to here is 15 minus 3, that will be 12. That much distance is covered in this total length, but we need only a will be 6, that's half of that. But now what's the midpoint here? What is exactly the midpoint? You can keep on counting like this, but otherwise it's very easy to find the midpoint. 12 minus, okay, now finding the midpoint, remember it's not at 0. If it was 0 and 15, it's 7.5. Yes, very easy, right? Now what happens is it's moved to minus 3. So the midpoint over here is a value. Half is 6. Somewhere over here it's 6. But don't write 6. We need to add this distance, right? Because 6 is in between these 2 points. But we have to go to the other side by 3 units. That means the midpoint over here 6. Midpoint here 6 is not 6 exactly. 6 plus 3, it will be 9. Minus 9. Look. Find the midpoint between these 2 points. Whatever the answer is, they add this distance. That will be shifted. So 6 is somewhere over here. That's not the midpoint. You shift by 3 units. Minus 9. That is the midpoint. That is it. So now this midpoint is obtained. We got the A value. We know the eccentricity E. So can we find the directrix now? Yes, we can find the directrix, because the formula for D will be plus or minus. The answer is plus or minus. I believe it was, yeah, divided is by eccentricity and A. I think so. Yeah, A. Yeah. So you should remember these formulas. I can't remember accurately right now, but I believe this is correct. Anyways, we'll see if it's wrong later on. It's better to write these formulas down and memorize it. Okay. Now then, can we just substitute and find? What is A value? It's 6 divided by E is 1.5. That's 3 by 2. It's 1, 2, 2 times 2 is 4. It'll be 4 plus or minus. Now this is not the directrix. I'm so sorry. It's the X value of the directrix. I'll tell you what this value means, okay, in a minute. But this value is very important. You can consider it to be X value of the, directrix. What this value means is, it's either plus 4 from the center or minus 4 from the center. This is what it means. The X value plus or minus the center will be the directrix. So this is minus 9. So the directrix will be either at, add 4 to it, it'll be minus 5, or it'll be at negative 13. So these are the possibilities of directrix, here or here, but you just have to choose one. Now, since it's writing question, you can just choose any one. I would just choose the one which is near the focus. This is the focus point. Minus 5. I'll just go with minus 5. So the directrix value is minus 5. And we know the graphing. Graphing can be done by calculator. I'll just show it again. But before that, let's write the equation. E value is 1.5. Directrix is phi. Don't write minus. Minus is because the value is minus in the bottom. Minus again 1.5, not E. Write it as 1.5 cosine theta. So that must be the answer. Let's just look into the answer. Here you go. That's the answer. If you multiply 5 times 1.5, you will get 7.5 itself. So this is it. Now over here they have considered phi itself. Okay, see, you can see it's minus phi. Now how would you graph it? I hope this much is clear. You can note this out. Only for hyperbolas, you have to do this extra part. This is the distance from the center, this x distance from the center. You get plus or minus. Take the one which is closer to the focus or the origin. Now let us graph it up. We have done it before. Again, let's do it in the calculator. First thing is mode and then 7 for table. Write the equation out. 7.5 divided by 1 minus 1.5 cosine x. Close the bracket. Now here start it at 0, end it at 360 degrees. That's 360. And let's give the steps of 30 or 45 degrees. So here at 0, what is it? Now this is minus 15. Let's see whether it's minus 15 from 0. Yes, this one, we are getting this curve, okay? So from here, minus 15, that's correct. Let's go to the second one. What will be the value here? At 45 degrees, it is minus 123. Is it true? 45 degrees, yes, it'll go somewhere. Say this keeps on going, right? It eventually meets at minus 123. That's fine. You can ignore that for now. But what about 90? 90 is 7.5. Yeah, this one we are getting 7.5. That is 7.5. And then, so 135 is 3.6. Is it true? Now here, 135 basically means what? It's going down over here. So this is the angle. Now this one, this is the first point we are touching. Yes, that is about 135 itself. And what next? 180 is 3. See now here 180, you can't take positive values. It's all over here, right? So it's positive, you take it to the opposite side, minus 3 basically. Okay. So yeah, this one is the one because it's this one. And similarly, you have enough points for this because if you know one of the one of the branch, that is enough because they're symmetrical to each other. So you can check the other points as well. 270, what that means is 270 is down over here. It's 7.5. Yes, it's very close to 7.5 and so on. You can go, you can try the other values. Now 360 over here is minus 1.5, so it goes over here. So that's how we get these points. Now, if you have got at least 2 points in one of the branches, then just join them. If you write the equation and this is not needed to be very accurate, you can just, get approximate value. And over here, it's symmetrical to that. And your directrix was at minus 5, so draw a dotted line over there. So that will be the answer. That will be how we graph it. So this is it. So that was the end of all the conic sections. Now we will deal with the complex numbers. Here you can see they have asked you to graph these complex number in complex plane and find its absolute value. How do we find absolute value? Absolute value is basically the modulus, and we have a simple formula that is equal to whatever the values are they, we consider it to be a and b, right? The standard form is given as za plus bi. So it is the square root of a squared plus b squared. That's it. So modulus over here would be square root of 4 squared plus 4 squared. That will be 16 plus 16 and square root of 32. You can just put in the calculator, you will get the answer. So it's square root 32, or you can write it as 5.66. Okay, now how do you graph this out? Let's look into this plane here. So easy. 4 positive, or just the 4 number, in the sense no I value must be there. See, this one is a real number, right? This is the imaginary part. The complex numbers has a real part, imaginary part. So our part is not having anything like no I or anything like that. It's just the number. that will be along the x-axis. So 4 is over here, 1, 2, 3, 4. Sorry, 1, 2, 3, 4 over here. And the imaginary part is the y-axis. So that is again 4 over here. So where does it intersect? This is the point 4 and 4. So you can see this R is for real part, I is for imaginary part. That's it. If you draw a straight line over here, that would be the radius given over here. So that's how we do that. And this one over here. Now let's look into the graph directly. Minus 3. So 1, 2, 3, left side minus 3 and 1. I is 1. So this is the point. Now do we find the modulus? The absolute value. That will be the square root of a squared. That is 3 squared. It's 9 plus 1. There's nothing means it's 1 over here. It's square root 10. So this is how we solve it. Now these are very simple problems. Just remember the part which is only having the number is the real part. The part which is having I is the imaginary part. Please try these by yourselves and then check the answers over here. This one as well. Very simple problems, all these ones. Here as well. And there's nothing difficulty in this. They're all same type. Here we have a different type of problem. It's about vectors. The force on an object is given by Z is equal to 10 plus 15I, where the components are measured in Newton N. Represent Z as a vector in a complex plane. Just graph these 2 points, which we did just now. Okay, it's also the same thing. Over here, 10, positive 10 on the real axis and 15 on the imaginary axis. Just make a point. That will be the line. And what next? Find the magnitude and direction. So this is now, magnitude is the same thing. What we need to do is absolute value, but direction is something different. So let's first find the magnitude modulus. That will be square root of 10 squared plus 15 squared. Now you need to use the formula first, which I had written before. Always remember for writing exam, write the formula, then the substitution, and then put in the calculator and get the answer. So let's just jump to the answer. Let's use the calculator and solve it. All you do is square root and just once 10 squared plus 15 squared. And the answer is 18.03. Okay, they did not tell to round it off to anything. Let us just take the modulus as 18.03. What about the direction? So the direction is given as theta, the angle theta. It is tan inverse of B by A. This is the generally used formula. But this changes. We add 180 degree if at all this A value is negative. So this formula is when A is negative value. Okay, this A value, A plus BI, right? But now this is positive, so we just use tan inverse of B by A. That's it. And let's substitute tan inverse of, what is B value? See now, if B is negative or positive, doesn't matter, just write it as it is. We only are concerned with the A value. If it's minus, we need to add this 180 degree. Now let's put this in the calculator. Shift tan inverse of, that is B divided by A. The answer is 56.31. So these are the answers. 18.03 and 56.3. Now, if at all they want it in radian, now generally they'll ask you, find the degree. It's in writing exam. You can just write in degrees only, okay? The direction angle, write in degrees. But if they specify in radian, then you can shift mode and 4. Now this is in radians, okay? 0.98 in terms of radian or pi. But if you just want in degrees, shift mode and 3. That's the answer. Now this one again, it's the same thing. Express the complex number in, okay, no, it's not the same thing. It's in polar form. I hope you remember the formula for this. The answer must be in terms of Z is equal to R cosine theta plus I sine theta. I is the imaginary part, sine theta is corresponding to the imaginary, whereas cosine is to the real part. Now, how do we do this? Is simple. We need to just find R and theta, which we did just now. R will be equal to square root of 4 squared plus 4 squared. We had done this before. So R, this is the answer. Theta will be equal to tan inverse of 4 by 4, which is 1, So here, all you do is put this as 1. And the answer is 45 degrees. So theta is 45 degrees. And what about this one over here? It is 4 squared plus 4 squared. Answer is 5.66. So 5.66 and theta is 45 degrees. Now just substitute it over here. R is 5.66 cosine 45 degrees plus I sine 45 degrees. So this is it. Now if you start simplifying this, if you put this in the calculator and solve, eventually you'll get this answer. You can try in the calculator, it'll be z is equal to, you know what is cosine 45? It's the same. Cosine and sine 45, it's a root 2 by 2. Uh, I'm just, no need of doing this, but if you do this, root 2 by 2 plus I times root 2 by 2. Okay, this is 2, sorry. Now, if you multiply this, I don't know what's the answer, but it won't be accurate, but it has to be 4. Let me show you. See over here, it's it's square root 2 by 2 times 5.66. It should be somewhere very close to 4 because we have not taken the exact values. We have rounded off, right? That is the question. But we just want the polar form, so don't do that. This is the answer. Now you can even write it in radians. Now this is correct, 5.66. What is 45 degrees in radians? It's pi by 4, isn't it? So we just write pi by 4 plus I sine pi by 4. See, if I was correcting your paper and if you are just written in 45 degrees, I would give you full marks. But sometimes they would expect you, because it's in polar form, to convert it to radians as well. Let's see what's the answer. Here it's, in radian form. But even this is absolutely correct. Don't worry. And they have taken the exact values. Okay, it's up to you. 5.66 is same as 4 root 2. So that is fine. Generally, nothing happens over here. But especially over here, when you convert to polar form, they write it in radians rather than degrees. Same thing over here. Now, I will do this problem because there's a little difference. R is simple. It's 2 square minus 2 square plus 1 square. The answer would be 5 square root 5. It will be 4 plus 1 square root 5. What about theta? It's tan inverse of, this is b by a. B is 1, by a is minus 2. But since this a value, 1 is b, a value is negative, you need to add 180 degrees. Or you need to add pi if it's in radians. So let's do this. Let's just put in the calculator. It'll be tan inverse, shift and tan, that is half, that is 1 by minus 2, or you can write minus 2 up, minus sign anywhere, it's fine, plus 180 degrees. And the answer over here is 153. Now they have written in radian. I'll show you how to get this radian. Now all you need to do is, instead of this 180, press shift and pi and change the mode, shift mode and 4. Now look at the answer. It'll be 2.677. That's 2.68. Pi and 180 are equal. So therefore we at pi, but since it's in radian mode, we cannot use degrees. We have to write in terms of pi and the mode in radians. So we get the answer in radians. That's how we solve this. Similarly, please do solve the other problems. Just that, say this is the a value, this is b value. A is positive, you don't add anything. Directly you get the answer. All these answers are written in radian modes for theta. Similarly, this one as well. You can do it by yourself and then check for the answers here. And here as well, as it is. Same thing here. Okay, now we have another type of problem. This is the power of complex numbers. What is this exactly? It's the Moivre's theorem problem, right? So let's do the same thing. What is R? A, B. So let's do it. 2 squared plus 2 root 3 the whole squared. You will get the answer directly in calculator. What about theta? It's tan inverse of 2 root 3 by 2. Since it's positive a, so I don't need to write plus 180. Now not 180, it's always about pi. Now let's keep it in radian, because you cannot solve this the Moivre's theorem in degrees. It has to be in radian for the formula. Now does anyone recall the formula? So it's basically like this: z to the power n. This formula the formula for this was given by de Moivre, so that's called de Moivre's theorem. R to the power n, over here you write cos n theta plus sine, okay, I forgot to write I, it's always imaginary part with sine n theta. So this is it. So now let's first find the r and the theta value. Here all we do is square root 2 squared plus, open the brackets, 2 square root 3 the whole squared. So brackets are important, otherwise only the square root 3 will be squared. So use the brackets properly. And now I have done some mistake. Okay, see, what is my mistake here? The brackets, I didn't use it properly. Sorry for that. This is 2 square root 3. Close the bracket and square it. Now it's all right. It's good that that error happened. Please don't do that in exams. So we got 4 over here, 4. Now what is the power here? It's z to the power 6. 4 to the power 6 into cosine. N is what? 6 itself. 6 times what exactly we are doing? Theta is tan inverse. Theta is tan inverse of root 3. Directly I'll write root 3 because 2 and 2 is cancelled off. Close the bracket. It's 1 by thirds of pi. So 1 by 3 pi plus I sine 6 times 1/3 of pi. Okay, so that's the theta value, and this is the entire thing multiplied. Now remember one thing here. Be very careful and understand this cosine n theta. This is entire thing together. Okay, so I'll just use a different type of brackets here just for you to understand. See that everything is for the sine. This everything is inside sine. So why it matters is, now let me solve it up. 4 to the power 6 is 4096. So over here z to the power 6 is 4096 multiplied by what? Cosine 6 times multiplied, or you can just put the bracket, it's fine, 1/3, or you can do this, it's 2 pi over here because 6 times 1/3 is 2, 2 times pi is 2 pi directly, but let me write it out over here. And pi is shift and this symbol here. Close the bracket twice because once for the cosine and once over here multiplied with 6, and the answer is 1. So let me write it as 1 plus I. What about sine? All I do is leave that as it is. Just change the cosine from here, delete it and make it sine. And the answer is 0. So multiplied by 0. This should be big brackets. Now that is 4096 times 1 because this is 0, right? So the answer is 4096. That's it. So the sixth power to this particular term is 4096. That's 4096. Similarly, this goes the same way, just like what we have done a while ago. Now, what they have done over here is, okay, they have just taken tan inverse. Let me see the previous one. Okay, this was much easier. Here you can see they wanted to take the exact value. That's why they have taken tan inverse entirely. I would highly recommend use 1.97 here, not all these terms, okay? And what do you have to multiply it with? It's multiplied by 3, so it's a little complicated over here. Let me just put this in the calculator and show you. So here, let me just take this part. No, they have already directly multiplied, so let me show you what's happening. 2197 multiplied by cosine, bracket is already open, 3 multiplied by bracket open. Now instead of all this, right, I just write 1.97. Close the brackets. The answer is 20. Okay, see, now I understand why they have written the exact value. See, if you use 1.97, it varies a lot, isn't it? See, the variation is 1045. It's supposed to be 1035, but if you put the exact value, that's why we, instead of 1.97, I'll put tan inverse, shift tan inverse 12 by minus 5, close the bracket and then add pi and again close the bracket. So that will be equal to, okay, I've done a mistake. See, now the brackets are not closed properly. Maybe okay, I had to write this. Okay, this is closed. This is also closed over here. 1, 2 brackets are closed extra. There's only one bracket. Okay, there's one extra bracket, so let me just remove that. So you can see the exact value is 2035. By the way, if you're getting confused with the brackets, see how many are open. 1, 2, 3. So closing 1, 2, 3. So that's it. So you can see there's a big variation. That's the reason why they have done this. But you can avoid that if you take, say, 4 decimal points. Instead of 1.97, take about 4 to 5 decimal points. You'll get a much accurate answer. That's the only thing over here that's done. I'll just show you over here. Tan inverse of 12 by minus 5 plus pi. The plus pi is because over here a value, see, minus 5 is the a value, a and b is the I, whatever is the coefficient of I, right? A is negative, that's why we add pi. So it's 1.96. If you have taken 1.9656, then you will get much accurate answer over here instead of all that. So that's the thing. And the same thing, this multiplied with the imaginary part as well. So that's how we solve it. Please do try these problems by yourselves. The solutions, the methods are also over here available. This one as well. Now, the previous one is very simple. Why? Because you don't have to convert anything. The radius is given. You just multiply this 4 power 4, then multiply pi by 2 by 4 and this pi by 2 by 4 and directly put in the calculator. And here as well, these are all solved up. Same thing here, even over here. And so depending on the n, see, this is the n. If it's in rectangular form, what you need to do is like x and y coordinates. You need to first find the radius, theta, then use the Moivre's theorem. Same thing, it's only power 2. This is easy because everything is given, you just take the power. This one as well. Now let's look into the different type one. Design. Suha works for an advertising agency. She wants to incorporate a design comprised of regular hexagons as the artwork for one of her proposals. Suha can locate the vertices of one of the central regular hexagons by graphing the solution to x to the power 6 minus 1 is equal to 0 in the complex plane. Find the vertices of this hexagon. So this is basically, what they're asking is find the solutions, right? Yeah, graphing the solutions. Basically, you have x to the power 6. I'll take minus 1 to the other side. It'll be 1. You need to know what are the solutions for this particular equation. It's 6x raised to this power 6. There are 6 different solutions. Now, they want it in complex plane. So what happens is, in order to solve such problems, because you have to solve square root, right? Or not just square root, it's power 6 over here. You need to solve by distinct roots. You need to find the 6 roots. There are 6 distinct roots by this one formula that is given as 1 by, you can consider that as n. No, you don't consider it to be n, sorry. You consider it to be something other than n, p or q. I'll take it as p. Why? Because we already have n in the formula. The formula is 1 by p, and you multiply it with cosine and then sine. Now cosine will be, it's always starting with the angle theta plus 2n pi, I believe, and p plus I sine. Here it's the same thing, theta plus 2n pi by p. Okay. I'm a little bit rusty. I did go through the formulas, but I don't have it written down. I'm just writing in my memory. Let me just check the formula and then let's get back. Yeah, this is the correct formula. Okay. So yeah, this is the correct formula. So this is the formula which we use for distinct roots. But here now, you need to have certain things. Everything must be in the polar form. So convert this 1 as r and theta. Now, how do we write it? Is this 0 I can be added. So we got a and b value. So what is r? R is equal to square root of a squared plus b squared. So r will be equal to square root of 1 squared plus 0 squared, that is 1 itself. And tan inverse of, this is positive a, so I'll just write b by a, that is 0 by 1. What is tan inverse of 0? it's 0. So theta is 0 over here, okay? This is all theta equals. So we got r and theta. Now you just substitute it in the formula. I'll show you here. It's 1 to the power. What is p? It's you want to take the root of this, right? 6. So it's 1 by 6 cosine theta is 0 plus 2 times. Let us leave this n for now. I'll tell you in a minute what that n is. And p is 6 here. Plus I sine 0 plus 2 pi 2, and n is also there over here, okay? N pi or pi n is the same thing, and 6. So this is the thing. Now here, there are 6 different roots, distinct roots. We start with n equals 0. Then we have to solve for n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and n is equal to 5. What this means is for each time you have to put this n as 0, n as 1, n as 2, and you will get 6 roots. So starting with 0, it will be p minus 1. P is 6, right? 0, 1, 2, 3, you count these, there are 6 roots here. So this is the formula we use. And now for the first one, what happens is 1 by 6 cosine. Everything is multiplied with cosine of what? This and this. Cosine of 0 plus 2 times again 0 pi. This n becomes 0 by 6 plus I sine. What is this? It becomes 0, sine 0. Why? Because when you multiply anything with 0, it will become 0. So now when you solve this, you will get the root for n is equal to 0. So, you know, we can easily solve this up. Why? Because sine 0 is 0. This is gone. And cosine 0 is 1. So it is 1 by 6. That is 1 itself. The answer is 1. But it will not be the same thing for the other because this 0 becomes 1. This n is 0 now. But in the next case, it will become 1. Let's look at the solutions over here. See, that is 1 and 0. After that, what we do is we substitute. Okay, now they have simplified. Now you can use the same formula every now and then, or you can get the reduced form and then solve it up. What I mean by reduced form is, see here, can you see this is 0? It doesn't change. Why? Because theta is 0 itself. Now then what do we have is we have 2n pi. This can be written as 1 by thirds pi n. So then we can just keep on changing 1 by third pi. They have just simplified it. It's up to you. Or you can just start using the same one and you can see solve it. Over here you can see they have used 1 by 3, see 1 pi by 3n, or you can write whatever we have written. This is the standard form. I mean, we use just the formula, substituted, and we did not simplify it further. So as you change the n value, you can see the values differ. You start getting the imaginary part and the real part. This is how we solve it. And see the 6 roots, 1, 2, 3, 4, 5, 6. 6 times you do it, right? Till n is equal to 5. These will be the solutions. So for this problem, all you need to do is take the 6th root. The p value will be 6. 6th roots, right? And then we do the same thing. Let's quickly try to do this problem. Z 1 by 6 will be equal to, I'm directly writing the substitutions. Now first R, it is just I, so it is A plus B I. A value is 0 plus B is 1I. So square root of 0 square plus 1 square, R is 1. What about the angle tan inverse of 1 by 0? So this is undefined. Where is it undefined exactly for tan inverse? Now if you try putting it in the calculator, tan inverse of 1 divided by 0, do you get any answer? You get a math error. Why is this? Because this is infinity, right? 1 divided by 0 is undefined. But if you take a huge number, what's going to happen? Something's going to happen because 1 by 0 is undefined. That's a huge number. If I take a very huge number here, you can see you will get 1 by 2 pi because 1 by 0 in itself is infinity and it cannot be processed in the calculator. But tan inverse of any huge number is pi by 2. So you can just use your calculator and find it out, okay, whenever you get this form. So we know it's pi by 2 now, or you can just memorize tan inverse of infinity is pi by 2. Uh, Here, what do we do is, okay, this is pi by 2. We got the angle theta as pi by 2. So we know the radius now and the angle is done. Now let's write it in the formula. R to the power 1 by 6, that is 1 to the power 1 by 6, multiplied by cosine. What is theta? It's pi by 2 plus 2 times n p. P is given as 6. So sorry, 2 times n pi over here divided by 6 plus I sine the same thing, pi by 2 plus 2n pi divided by 6. Now then we can simplify these. How do we simplify? Now you can't leave it like this instead of simplifying, Generally in your textbook, what they do is they simplify this how much they can and then they use that form. But here, sixth root. So n is equal to 0. You need to just substitute n as 0 and solve it. But since it's written exam, you need to substitute it. In the sense, you have to put 1 by 6 cosine pi by 2 plus 2 times 0 pi by 6 plus I sine pi by 2 plus 2 times 0 pi by 6. I hope that they may not give you a long question like sixth root 6 times no, and they might give you maybe second root or something like that, or 3 roots. That's it. So for the next one, you do n is equal to 1. Here the same thing, 1 by 6. Instead of wherever n was 0, you put 1. So this keeps on changing. And then you just put that in the calculator and solve. Over here, you just solve this entirely in the calculator. Let's write cosine. Pi is shift and pi here by 2. Now let me write it as over here another fraction, pi by 2 plus 0, because everything becomes 0, divided by 6. Now the answer is 0.959. Let's see how they have written. Okay, they have written it in terms of, yeah, this much only. I thought, see, either they write like this, but this is a huge number. They simplify it and write it in terms of 0.97. Because outside is 1. When you multiply 1 towards this number, it's the same thing. Now the same value, just change this cosine to sine here. So once you put that in the calculator, it's easy to find the next one. It's 0.26. But don't forget the I. Next, you change that n value to 1 and you solve the same thing. Then you change it 2, 3, 4, and 5, and 5. That's the last one, because 6 root means you start with 0 and end at 5. And these are the approximated roots, the 6 roots. So this is how we can solve these type of problems. Please do try them by yourselves. There are plenty of problems. You can go through the methods as well. You can just pause the video and go through them. But first solve it by yourselves and then check the answers. Even over here, it's the same thing. First, you need to find r, theta, then use the formula for distinct roots, substitute, and then solve it. Here as well. Now, what is cube roots? It's only 3 times. N will be 0, 1, and 2. That's the 3 roots we are to find. Fifth roots is 5 times. So 0 to 4 over here. And square root would be just 2. That is 0 and 1. That's it. You can see here. After the writing the formula, we are just use n as 0 and n as 1. Only 2 roots. Now find the square root of unity. Unity is 1. Basically for 1, we are just solving. Just like the real world problem which we did. So here for the unity, it's just plus and minus 1. Now, square root of 1. What is the square root of 1? It's plus or minus 1, right? It's just common. You would know the answer, but you have to do the method. This is very important. Only then you'll get the proper marks. And fourth root of unity, just carry forward 2 more times, 2 roots are plus or minus 1, and then you are plus or minus I. That's it. So that's finally the end of question 2.